Audhayan Academy is dedicated to bringing interesting lectures with solved example questions on a variety of subjects with critical concepts. For topic-based worksheets with detailed solutions, go to our website, audhayan.com. If you enjoy our videos, please like, share, and subscribe. Now we'll be discussing question 5 of year 2016, variant 4.1 MJ. So in this question, dicarboxylic acids dissociate in stages, stage 1, stage 2, and we've been given those stages. The pKa values for stage 1 and stage 2 for some dicarboxylic acids are listed below. So let's have a look at the table. Alright, for comparison, pKa value of ethanoic acid is 4.76. So let's proceed with the question. We've been asked in the first part to state the mathematical relationship between pKa and Ka. So let's write it down. pKa is equals to minus natural log Ka. In the second part, with reference to the table above, suggest why pKa1 values are smaller than pKa of ethanoic acid. Well, diacids have, as we can see, the diacids have 2 electron withdrawing groups, and ethanoic acid has only 1 electron withdrawing carboxyl group. So we can write about that. So we can say that the diacids are more acidic than ethanoic acid, as they have more carboxylic acid groups or carboxyl groups, which are more electron withdrawing, stabilizing their anions more to release greater number of H+ ions. And instead of writing more carboxyl ion groups, we can write they have 2 CO2H groups, causing, whilst ethanoic acid has 1. Let's just add that. Let's continue with the rest of the answer. Causing diacids to be more acidic. Then we are asked why the pKa value of ethanoic acid is larger than that of the diacids as N increases. And N here is the number of alkyl groups within the diacids. Now, as N increases, the distance between the electron withdrawing carboxyl groups also increases. So this decreases the electron withdrawing effect, and at the same time, as the number of alkyl groups increases, we can say that the number of electron donating alkyl groups increases, and hence the anions that are formed are no longer stable because the oxygen in the OH bonds in the carboxyl groups now have greater electron density. So we can write acidity decreases as size of electron donating alkyl groups increases, and so the anion, sorry, no comma here, the anion is no longer stable. For part 3, they ask that suggest why all the pKa2 values in the table above are larger than the pKa of ethanoic acid. Removal of hydrogen ions of monoanions is not electrostatically favorable. Meaning, since the pKa values are much larger than that of ethanoic acid, we can say that the diacids in stage 2 are less acidic because as pKa increases in value, pH also increases, meaning less hydrogen ions are released, causing pH value to also increase. So this means that hydrogen ions are not easily released from the monoanions. Therefore, we write that the removal of hydrogen ions from the monoacids is not electrostatically favorable. Now for part B. The monosodium salt of edible dicarboxylic acids are added to some foodstuffs as buffers. Explain what is meant by buffer solution. Well, we wrote this before. Let's write it again. It is a solution that resists change in pH when small amounts of acid or alkali is added. Now write two equations to show how monosodium butane dioate acts as a buffer. Well, like any buffer system, we have to write the equations using a hydrogen ion and a hydroxide ion. So let's write HO, so 2C, CH2, CH2, CO2 Na plus H plus, which will give us O2, CH2, CH2, CO2H plus Na plus ions and HO2, CH2, H2, CO2, Na plus hydroxide ions, which gives plus a H2O molecule. Remember that for any reaction in a buffer equilibrium with hydroxide ion will always form a water molecule, and in any reaction involving a hydroxide ion, the hydroxide ion will be incorporated into the main reactant, is this one, and if needed an ion will form on the side. That is it for this question. I hope you have understood all that has been explained in this question, and for the worksheet please visit adhyayan.com, where we have worksheets, their solutions, and all our YouTube videos, and soon we'll be introducing quizzes. Please like, share, and subscribe. Bye.